Hey everybody, how's everybody doing today? First of all, I'd like to thank Kasha and the team. I think speaking for myself and having lived in front of customers and talking about technologies in this industry for 28 years, it's nice to get back to doing it in person. So it's really nice to see a lot of the old friends that I've known for a long time, and certainly happy to be meeting some new friends. So thanks to everybody for coming. I want to talk today about the ability to make an interconnection, to make device attachment, component attachment into the flexible hybrid electronic world, as well as in the wearables world. It's really one of the first opportunities in 28 years of selling conductive inks and polymer thick film products into the printed electronics world, where I've had the opportunity to work for somebody that's really developed what I thought was a definite game-changing innovation in the industry that's going to help enable a lot of the kinds of things that we're seeing today, a lot of the wearable technologies that we've heard about for years that are now becoming a reality. We are built and designed around delivering that technology. The original version of this technology is not brand new. The original technology that we built our company upon was used by AT&T Bell Labs. Their founder is our CEO's father, and their chief technical officer is our CEO's founder, and he used this technology. He invented it, and it was licensed to them in all the first push-button telephones that they had developed. So what we've done is taken and innovated this technology and brought it to a kind of a new level of usability, much easier to process, and we'll talk about that. So if you think about where we are in the printed electronics space, I mean, I think to when I started in this industry in 1994, it was really just membrane switches on white goods, and it was all made in Germany and North America. And it was standard polymer thick film inks getting screen printed on a flat surface, and then working toward integrating device attach. Usually it was LEDs, there were some resistors and other components. The technology that was used then is a lot of the same technology that was used today, although it's been modified and innovated. But those technologies were really the same way they were making device attach on circuit boards many years before that. And I think that's always been the issue. You look at the future of printed electronics, where we've got flexible sensors, wearable monitoring technologies, smart technologies. All of those have to be more integrated in our day-to-day life. And if you look at the way that was done a long time ago, the problem was that there were size limitations to what you could do with the technologies that were available. We had weight limitations. Most of the materials were not flexible. You didn't have a lot of durability in these products. They weren't used in the highest performing devices. You still had a lot of rigid circuit board applications. They're also expensive to produce. They required high temperature processing. Most of them operated in either harsh materials, or they didn't operate well in harsh environments. They were capital intensive. What we've found and what we've seen from a lot of the companies that we had experienced in the conventional ink business was those products were also migrating and getting developed to innovate into these wearable technologies. The die-attach technologies, the interconnect solutions really weren't. When you look at those, you see things like low-temp solder. It's very cost-effective. It can be processed in scale at fairly high speed, but it has limitations when it comes to the pitch that it can manage. You still have to pattern the material. Most of the time, you'll either have to underfill or encapsulate to protect from high usage. It doesn't really have miniaturization capabilities beyond a certain level, and its cyclic fatigue is really extreme when you get into harsh environments or wearable applications. Not a good application for it. Then we have anisotropic conductive films and anisotropic conductive adhesives. Really good innovation, really exciting method. I mean, the technology's been around a long time. I started my career at Atchison. We had a product that worked for a lot of applications. I think Henkel had still been selling some of those materials till not too long ago. The problem you had is you still had high loading of the conductive particles. It required a thermode to process. You really didn't have tremendous adhesive bond with a lot of these materials. And you had limits to things like how fine a pitch could you manage. Miniaturization was an issue, and it still didn't have the kind of cyclic strength for wearable or high-functioning materials. And then, of course, there's traditional ECAs, electrically conductive adhesives, been around a long time, very good for making die attach on larger materials. You still have to pattern them. More often than not, because of the silver loading in those products, you also have much higher content of the silver or other conductive particle, which means you're not going to get tremendous bond strength. And because you can only make the interconnection at the circuit and the die bump or the pads, you don't have a large area that you're working with, so the device still has to be protected, whether you're underfilling, encapsulating, or both. These are all things that create issues. You have thermodes to process the ACF and the ACA materials. Once we get into these thin, highly